Okay, so let's take a look at the questions on page 708, which have to do with resistance. And you're going to need to use those two charts that I was showing you in the other video. So 16 says, what is the resistance of 200 meters? So that's 16. 200 meters is your L, except it's 250 meters of aluminum wire. So you look in your chart and you find out that the resistivity of aluminum is 2.7 times 10 to the negative 8 ohm meters. What is the resistance that has a diameter of 2 millimeters? So diameter is 2 millimeters, which means the R is 1 times 10 to the negative 3 meters, right? Because half of it is 1 millimeter and then times 10 to the 3. So probably the first thing you might want to do is find A. A is equal to pi r squared. So A is equal to pi times 1 to the negative 3 meters squared. I'd be tempted to write this as pi times 10 to the negative 6 meters squared. Now you can't fill that in your calculator like that because your calculator won't let you, but you'd have to write it in as pi times 1 times 10 to the 6. So then we go over to R is equal to rho L over A. So rho is 2.7 to the negative 8 ohm meters. L is 250 meters. And then A is our pi, 1 times 10 to the negative 6 meters squared. Type all of this into your calculator and you should get a resistance of 2.1468. Couldn't tell if it was a 4 or a 9. 2.1468 ohms. Okay, number 16. Number 17. What is the length of 18 gauge nichrome wire that has a resistance of 5 ohms? So you're looking for length. What is the length of 18 gauge? So on the little chart on the previous page, you look and you see that 18 gauge has a diameter of 1.02 millimeters, which means the radius will be 0.15 millimeters, or 0.15 times 10 to the negative 3 meters. It's nichrome, so while you're on that page looking up the gauge, you may as well look up the resistivity. It's 100 times 10 to the negative 8 ohm meters. And it tells us it has a resistance R of 5 ohms. Okay, so again, first step, I would find my A. A is equal to pi r squared. So A is equal to pi times 0.15 to the negative 3 meters squared. This time I would have to use the calculator to get my A. It's 8.171 times 10 to the negative 7 meters squared. And then I go to R equals rho L over A, and I'm solving for L. So L is going to equal A times R over rho. So L is going to equal 8.171 to the negative 7 meters squared. The R was 5 ohms. And the rho was 100 times 10 to the negative 8 ohm meters. Okay, and when you do that, you should get an L of not zero, of 4.086 meters for your L. It's number 17. Number 18 says the resistance of a 100-watt light bulb. So that's power. I don't think we even need it. I think they just tossed it in there. Light bulb is 144 ohms. So R is 144 ohms. If tungsten filament is 2 centimeters long, so L is 2 centimeters, or 0.02 of a meter, what is the radius? And it tells us it's tungsten. So again, you have to go back to your chart. And you find out that the resistivity of tungsten is 5.6 to the negative 8 ohm meters. And so you're looking for what is the radius. So you're going to start with r equals rho L over A and solve for A this time. So A equals rho L over R. So A equals 5.6 times 10 to the negative 8 ohm meters times 0.02 meters, and R is 144 ohms. So when you do this, you get A equals 7.7, might be repeating, but I have an 8 here, times 10 to the negative 12 meters squared. Once you get this, then you go to A equals pi r squared. So r squared equals A divided by pi. So r squared equals that 7.78. All the decimals you have in the calculator, leave them. I just didn't want to write them all down. Divided by pi. And remember, this will be r squared. You get 2.4757 meters squared, but then you have to take the square root, and you get 1.5. Oh, I think I lost times 10 to the, must be negative 12. 1.573 times 10 to the negative 6 meters is your R. It's a pretty tiny wire. All right, number 19 says, an extension cord is made of 14 gauge aluminum. So again, you have your 14 gauge, so you go and you find out that 14 gauge has a diameter of 1.63 millimeters, which means the radius is going to be 0.8015 times 10 to the negative 3 meters. 0.8, is it 1.63? Oh, there's no 0 here. It'd be good if I could do math in my head, wouldn't it? So 0.815. Continuing to read, it says it's aluminum. So look up the resistivity of aluminum on the other chart, 2.7 times 10 to the negative 8 ohm meters. And it says calculate the resistance if the length is 35 meters. So L is 35 meters. Okay, so again, find your A. A will be equal to pi r squared. So A will be equal to pi times the 0.815 to the negative 3 meters squared. And you should get an A of 2.0867 times 10 to the negative 6 meters. Then you go to R equals rho L over A. Rho was 2.7 to the negative 8 ohm meters. L was 35 meters. And A was our 2.0867 to the negative 6 meters. Punch this in your calculator and you should get a resistance of 0.453 ohms. Okay? And number 20 says a square carbon rod is, now it's square this time. Okay? So, and it says that it is 24 meters long. So L is 24 meters. And its resistance is 140 ohms. And it says it's carbon. So look up carbon in the resistivity table, and it's 3,500 times 10 to the negative 8 ohm meters. Not a great resistivity. And the question wants to know what its width is. Its width. So first step, find A. Rho L over A. So A is equal to rho L over R. So A is equal to 3,500 times 10 to the negative 8 ohm meters times 24 meters. Going to run out of time. Divided by 140 ohms. And you get an A of 6 times 10 to the negative 6 meters squared. And it's a square carbon rod. So A is just equal to width squared. So the width is the square root of A. So the square root of 6 to the negative 6